All right, question number 10. We have some data of pulse rates, beats per minute of 9 students. We're going to treat these 9 students as the population, and we're going to compute the z-score and the mean. We're going to compute the mean and standard deviation of these z-scores. So it says round to the nearest hundredth, so we're going to round to 2 decimal places. So I'm going to copy this data in Excel since I'm going to be doing multiple computations. So I'm going to call this the mean. Let me go up one actually. It's going to be the mean. This is going to be standard deviation. I'm just going to say sigma. And we'll call this the z-score, z. Alright, so I'm going to do a formula here. I'm going to say that this square is equal to this value minus the mean, which I'm going to put here. And I really need to put these in parentheses. This is going to be divided by the standard deviation. Let me go back up to this formula. I want to add parentheses here because if we don't, it won't do the subtraction first. Order of operations will do the division first, and then it will subtract, and I want this to happen first. So this is z-score formula. Just remind you of that over here. Z equals x minus the mean. Since it's population, we're going to do mu divided by sigma. Okay, so this is what I'm doing. I'm just typing it in here. Now, once I enter the data, it'll compute. It's not doing anything because I don't have numbers and I'm dividing by 0. So if I was to click and drag this down here, the formula repeats. Now, it's doing B3 and F3, so it's grabbing down. So I'm going to have to copy the mean and sigma, which is going to be the same for all of them, all the way down. So I'm going to have to do that. So right here, we're going to go to formulas. We're going to go to more statistical, and we're going to find the average. I want the average of these numbers here. Okay. Let me see if that will copy down. I don't know what that did. What did this do? Went to B11. I'm just going to copy, Control C. Nope. Let me delete that. It's copying the formula. I want to copy the value. Right click, copy. It's still doing the formula. Let's just say the B10. Average is doing B3 though. So it is. So let's see if it'll copy the same. I want it to copy the same formula. Okay, will it copy all the way down now? No, it keeps changing it up. So let's just type it in, 72.222. Just type enough 2s, it should do it. And then I'll just copy this all the way down. Okay. Normally it doesn't do that. Sometimes it'll allow you to right click and copy some options, and it'll let you copy formula, copy value, but I'm not seeing that now. So anyway, we're going to compute the standard deviation. Statistical, we're going to do the population standard deviation, so STDEVP for population. I'm going to do these values as well. Okay, so that gives me, I'm just going to type that number, 7.61 0.26125.3. So that's enough decimal places. Even though there's more, that'll be enough. So it computes all the z-scores for me at once. Everything looks good. Okay, so we're going to enter those here. We're going to round it 2 decimal places. So 0.63 for the first student. Second student, negative 1.61. Third is negative 1.61 as well. Fourth, 1.02. The fifth student, negative 0.03. The sixth, 1.02. The seventh, 1.02. The eighth, negative 0.55. And the ninth, 0.10, which is 0.1. Okay. This one wants us to compute the mean and z-scores, the mean of the z-scores. So the average of the z-scores is just going to be the z, or the mean of these guys. Let's compute the average. We're going to round to the nearest tenth in 1 decimal place. So we're going to do formula statistical. We're going to find the average. And I'm going to click these boxes. So we're going to find the average of the z-scores. So this is saying the average is roughly 0 because this is 2.012 and it says e to the negative 8. So that means we would move the decimal place over. It's a weird computation. I might need to do this in a calculator just to double check. I'm going to do it with these numbers. Alpha y equal enter. Which it should be 0. Some will be greater than the mean, some will be less. When you add these up and divide by 9, you should get 0, that's what it's saying. And then the standard deviation of the z-scores. I guess we're going to stick with population, so we're going to go statistical standard deviation of these guys. And it's giving me 1. So what this is saying, or a better way to interpret just the mean of the z-score and the standard deviation, once we compute a z-score, if you recall the empirical rule, let's say you have a mean of like 63 maybe, and your standard deviation is 7. So one standard deviation would be 70, another one would be 77, and another one would be 84. And then you subtract 7, you would be at 56. Subtract 7, you'd be at 49, and you'd be at 42. This would be like a regular bell curve. Whenever you apply the z-score, what we do is we're shifting this curve backwards to where my mean is now 0, which we're going to find out a little bit more about that standard normal. The mean is 0, and the standard deviation is going to be 1. So 2, and then 3. And then -1, -2 standard deviations, -3. So that the information between 56 and 70, which would be 68%, it's going to be the same between -1 and +1, 68%. So all it's doing is kind of shifting your bell curve so it's centered around 0 instead of some number. It's easier to count 1, 2, 3 on either side than counting by 7s. It takes a little work, but it's not as quick. So that's the idea here.